All right, so now we're going to take a look at probably one of the more important aspects of not just chemistry, but science in general, and then also how um, what we're going to be talking about is related to your course that we'll be doing, which is making measurements, right? So we've talked a little bit about measurements already. We kind of alluded to some of the units that we'll be seeing down the road. Then we also talked a little bit about uncertainty in measurements and how that is dictated by the instruments that are being used. And then you would get some practice doing and making measurements in lab in our first lab meeting. Now, the other thing that you'll be getting some practice doing is also using the different measuring units and different measuring systems as well. So just to give you sort of a framework or a reference for why this is so important and give you two sort of dramatic examples of where this is important. So for example, back in, I think it was 1983, there was an incident called the Gimli glider. And the idea behind this, or what happened here was there was an airplane, it's a Canada flight going from, I believe it was Montreal to Edmonton. So if you're familiar with Canadian geography, Montreal is on the east coast, Edmonton is kind of like in the middle of Canada, in the plains, for example. So it's a fairly long way. And when they fueled the plane, they calculated that they needed a certain amount of fuel, somewhere in the order of maybe 40,000 kilograms of fuel in order to get from Montreal to Edmonton. And instead, that was needed, what they actually filled the plane with was actually 40,000 pounds uh, of fuel. So that's the amount that was actually added to the plane. Now, as you can imagine, kilograms versus pounds are very different things. So this is actually maybe about what was needed. And the reason why this happened is because Air Canada at the time was in the process of converting from the imperial system pounds to the metric system kilograms. And the people who were servicing the plane actually did not do the conversion properly. And they filled it with about half the amount of fuel. So what happened was the flight actually ran out of fuel. And it actually had to glide uh, onto I believe it was an empty racetrack or something. When it ran out of fuel, it glided, eventually landed. Nobody died or anything like that, but it could have been a lot worse than it actually was. And again, that was due to the skill of the pilot. So this is a fairly, dramatic example of where units specifically are important. Okay, so a kilogram is not the same as a pound, and making that not knowing the difference there is not too big of a deal, but in this particular situation, fuel on an airplane, it is a huge deal, or it was a huge deal. All right, so we're not going to necessarily be fueling planes and stuff like that, but we are still, or you are still going to be making measurements. So for example, you have to determine the size of a room. So you measure, the dimensions of a room to calculate, airflow or whatever it is that you need to calculate. Well, you need to decide, are we going to be measuring that in feet? Are we going to be using meters? Or are you going to be using yards? What is it? When you say a room is, 7 by 10 by 5, well, what is that? Is that 7 feet by 10 feet by 5 feet? Is it 7 meters by 10 meters by 5 meters? They're not the same. They're very different, as we'll see. So it's really, really important that you pay attention to your units because they do make a difference, especially when you calculate things, but also, as we just said, in this fairly dramatic example with an airplane. And I'm just going to clarify the numbers here. I made these up. I just looked them up and they're not 40,000. The plane actually needed 20,000 kilograms, and they only put on about 20,000. Right. So the units, either way, whether it's 40 to 40 or 20,000, the difference there is the unit made a huge difference in how far that plane could actually go. So it only went about halfway to Edmonton before it actually had to land at an airfield or a place called Gimli, which is where the name actually comes from. All right, so in science and chemistry and physical sciences, we are not typically going to use the imperial system. Okay, so the imperial system of measurements, things like feet, inches, gallons, etc. Instead, what we are going to use is the metric system. And there are reasons why we use a metric system, which we'll talk about in a second. The metric system was developed back in the 19th century, so it's 1800 and then since then, the metric system has evolved into what is known as the SI system. And SI stands for System International. It's a French word. That's where the SI comes from. Sometimes we do the international system of measurements, as we swap where the S and the I is. And this SI system has established certain units, 7 basic units to measure different quantities. So basic SI units that we're going to see are things like the following. And some of them we see more than others. So for example, there are 7 of them. So for time, we use the seconds. Okay, and seconds. We're fairly familiar with that. For length, we use the meter. So sometimes seconds is abbreviated S. Meter is abbreviated small m. Seconds is small s, by the way. We also have mass, the amount of matter in something. And this, the basic SI unit there is kilograms, kg. Let me actually write that out first. Kilograms, small k, small g. And remember, mass here is the amount of matter in something. Right, so mass, measure of the amount of matter, measured in kilograms in the basic SI unit. We have electric current. Which is measured in amperes. Oops. The abbreviation. We also have temperature. The SI unit for temperature is Kelvin. Is abbreviated big K, uppercase K. Yes, 1, 2, 3, 4, 5. We have a couple more. We have amount of substance. The unit for this is the mole, which is abbreviated MOL. That's not much of an abbreviation, but that's what it is. And then something we don't see quite often is luminous intensity. And that is measured in candela. And you can imagine it kind of sounds like candle. And these are the 7 basic SI units that have been established, right? Some, like I said, we're going to see more than others. Some we're going to see way less frequently, like candela, for instance, and others we're going to see like meter way more frequently. So we've talked a little bit about some of these already, and we'll continue talking about them here in this section. So adoption of that SI system allows several things to happen, and it makes it a little bit easier to work with measurements. So for example, when we communicate from regarding stuff like the weather to different forms of life. We can communicate quantitatively, right? So we can use the same system to communicate amounts to people, and we're all using the same system. Just like with pound versus kilograms, well, if we establish a particular system like kilograms and we say 15 kilograms, you know exactly what we mean. That facilitates, for example, the exchange of products between different countries, or all the countries agree they're going to use a certain system. And then computations, which is very, very important. Computation of calculations. Using the SI and by extension, the metric system is going to allow us to do these computations and calculations a lot quicker and a lot more straightforward, because the conversions, the relationships between the different units are going to make a little bit more sense, right? Because these factors of or decimals for different magnitudes. Of measurements. So for example, and we'll talk a lot more about this here in a second. So if we say, for instance, a meter is the same as 100 centimeters, right? This is the same as 10 to the 2 centimeters. And a meter is also equal to 1,000 millimeters, or 10 to the 3 mm. Okay, so with this simple example, you can see the relationships between, in this case, prefixes in the metric system. They are related by a factor of 10. You have 100 centimeters that make a meter, 1,000 millimeters that make a meter. That means then if you compare these two, then there's 10 millimeters in 1 centimeter, right? As opposed to using the imperial or the British system, when you know, oh, it's 12 inches in a foot, okay, and then maybe there's 5,280 feet in a mile. Okay, well, there really isn't no rhyme or reason to these different relationships here, but there was a definite relationship using that those metric units in the SI system, and that's the hallmark of it. That makes it so user friendly. As long as we can work with powers of 10, it'll be a lot easier to navigate through some of those.